Hello, hello, hello. Am I live? It says going live. I'm live. Hey, students. So I thought we'd go over the reading, reading about electricity and the simple plan I sent last week of the ADU and how that kind of pertains to it. We'll intermingle those two worlds because if you know how electricity works, it just makes reading the plans that much easier. So this is kind of a twofer. So this was the reading, the basics of electricity that I know you all read, super interested in. This was the plan we went over right here. So I thought we'd just do some follow-up on this, and there will be some questions that come out of this. I have to give you a final, but I'm going to give you all the questions prior to the final. I'm not one of these guys that springs. I found that in the classes that I did that in, where they gave me the questions, the teachers gave me an opportunity to come to a study session where they gave me all the answers. I actually still remember a lot of those things rather than just getting a quiz and going in blindly. I don't think you learn very well doing that. So back to electricity and how it flows. They use the water analogy, which is a good analogy. So we'll just keep going on that. But basically, you have power coming in, you're hot, you have a switch, that's the symbol for a switch. The power comes into one side of the switch here. So there is no connection. The switch is open. The switch goes over to a light, symbol for light. However, this switch is open, water is not flowing, the valve is not open. When this switch closes, click, now you have electricity flowing to the light. It turns on in 1/100 millionth of a second, or the speed of light. So that is how water flows. The analogy of electricity flowing. Same deal with the river. You know, they talked about the waters here. You displace the water, it flows to the next source, turns on the light. Same idea. So that's how electricity works. Now, why do we use AC in homes versus DC? What is AC? AC is alternating current. Let me see if I can do that better. Alternating current. DC is a direct line, positive to negative. Alternating current can travel much farther distances, hence our power from the Hoover Dam coming hundreds of miles down to us, and we still have 120 volts. DC drops off quickly. As you'll learn, the next set of plans we go over is the landscape set of plans. It's DC, 12 volts, right? At the transformer, you can have 12 volts. After 100 feet, you're going to lose a volt. You'll get 11 at your light down here. No, you can't see that. Your light down here. So you'll put your meter on here. This will say 11. It might even say 10. At 9, the light will not light up. Say you are 300 feet away. So how do you get that 12 volts all the way 300 feet over to still get maybe 11 so the light turns on? You upsize the wire. So bigger water pipe. Say you were using 12, use 8. Therefore, that's less resistance. The electricity will flow more. Less resistance, you get the wattage that you want, the voltage down at the end. So little quickie there, but why we use AC versus DC? This will be a test question because it can travel better over longer distances. The next thing, does a live wire coming off, we'll say a light or a power pole, this is the ground, does it have potential? The answer is yes, it is live here. However, air is a wonderful insulator, a good insulator. This will not strike here. But so many people are inclined to say, hey, there's a live wire, and touch it. Well, now it has quickest path to ground. You're a goner.